Good morning. You are listening to Sir Bryce Mugwe. And today we are going to look at how the levels of carbon dioxide are kept constant in the body or kept to a minimum. You will notice that if there is a slight increase in carbon dioxide, then breathing rate increases. It means you start breathing very fast. The reason is because when carbon dioxide increases, carbon dioxide is toxic when it increases in the body. You need to send it out very fast to reduce toxicity. And then we need to look at what happens, why you have to breathe out fast to send out the excess carbon dioxide. And this in itself is a homeostatic mechanism. So it involves homeostasis to maintain the level of carbon dioxide in the body. Carbon dioxide, where does it come from actually in our body? Part of it, we inhale it during inhalation, but most of it, we produce it in our body through the process of cellular respiration, which involves the oxidation of the food or the nutrients found in the cells that we have taken in to produce energy, but carbon dioxide is produced as a byproduct as well and must be taken out of the body. For the carbon dioxide to be taken out of the body, first it must leave the cells and carry it to the lungs. And who carries or what carries the carbon dioxide to the lungs? It is the blood cells, the red blood cells flowing within the blood vessels. So inside those blood vessels, there is not only blood flowing there, there is also plasma which flows in the blood vessels. And plasma is mostly composed just of water. It therefore means that when carbon dioxide is transported in the blood vessels, it comes in contact with water. And we need to understand this part so that we can clearly understand the link between carbon dioxide and blood pH. But first, blood is normally found at a pH of 7,4. And that pH is the best pH for most bodily functions. And this is due to the fact that enzymes function best at such a pH, since enzymes are sensitive to changes in pH. Therefore, the overall pH of blood must be kept around 7,4 for enzymes in the body to function properly. Hence, when carbon dioxide is transported in the blood vessels, carbon dioxide combines with water. So we shall have carbon dioxide combining with water to produce H2CO3. And this in itself is carbonic acid. This is carbonic acid. The carbonic acid later on dissociates, so it will break down to form a hydrogen ion plus a bicarbonate ion. From our basic chemistry, we know that the hydrogen ion here represents, according to the theory put forward by Bronsted-Lowry, it represents acid. So when we see hydrogen ions, basically we're looking at acid. And the bicarbonate ion would represent a base, the opposite of acid. Now, what does this hydrogen ion do to the pH? The pH scale ranges from, say, 1 to 14, with 1 being 1 to 6 or 6,9 being the region of acidity. So we find acids here. And 7 is neutral, that is the pH of pure water. Therefore, the pH of blood that we expect should be at about 7,4, somewhere there. And the other side from 7 upward is basic, is the base or alkaline. Therefore, 7,4 means a slightly alkalinic pH. That is the pH of the normal pH of blood at which most enzymes would function optimally. But then, when we have an accumulation of hydrogen ions that have been produced here, since hydrogen ions bring about acidity, it means that the acidity of that environment, when hydrogen ions go increase, the acidity as well will rise, it will increase. It's a little bit tricky because our strongest acid is around 1 here. It means an increased acidity leads to a decreased pH. You see that we're moving from 6,9 towards 1. That's because acidity increased. And what increased acidity? It is the increase in the hydrogen ions. Will the enzymes be comfortable at such pH? The answer is no. That is why we have to look for a mechanism that will help us to decrease the acidity, otherwise increase the pH and bring it back to about 7,4, where most enzymes function best and comfortably. Hence, we need to look back at our equation here. If I have to decrease acidity, what must I take out? I must take out the acid, and that acid is the proton here, the hydrogen ion. I need to take that out. But how do I take out hydrogen ion? First, I must understand where is it coming from. The hydrogen ion directly comes from the carbonic acid here after dissociation. It means to take out hydrogen ion or to reduce hydrogen ions, I must reduce the level of carbonic acid. It brings me back to another aspect. Question again, where does carbonic acid come from? Carbonic acid we see here comes from the reaction between carbon dioxide and water. Therefore, if I want to reduce carbonic acid, what must I reduce or what must I take out? It means I must take out carbon dioxide because it is carbon dioxide that created carbonic acid after its reaction with water, and carbonic acid created the hydrogen ion after dissociation. So we see here a direct or indirect link between carbon dioxide and hydrogen ion, a direct or indirect link between carbon dioxide and acidity, a direct and indirect link between carbon dioxide and blood pH. That's how carbon dioxide and pH are linked. We need that first to understand that. It means that the higher the level of carbon dioxide, the higher the acidity, which also means the lower the pH. Remember, the strongest acids are at pH 1. It means when we go up in pH, acidity is decreasing in strength. Therefore, an increase in carbon dioxide will mean what? A decreased blood pH. That is what we need to first understand here. Now, next, when we look at the hydrogen ion that is produced, the one that we want to take out, it has more or less a chemical nature. So we need to remember that it is a chemical. Now, if I want to fix a problem, first I must detect that there is a problem. If I want to bring about a solution, first I must detect that there is a problem. That's the first thing I need to find out. I must detect that there is a problem. So here there is a problem. there is an increase in hydrogen ions. Otherwise, there is a decrease in pH. That is a problem. But that problem needs to be detected. Therefore, in the body, there are structures that are able to detect such problems, which are changes in certain body parameters. And these structures that are able to detect, we call them receptors. Now, we ask ourselves, which receptor will be able to detect this hydrogen ion? Remember, hydrogen ion has a chemical nature. To find the receptor, it's very easy. Most receptors are named by using part of the names of the substance that they have to detect or the parameters that they have to detect. So we are using part of those names as prefix. Therefore, to detect hydrogen ion changes or to detect such a chemical, I will need a chemo. Chemo comes from the word chemical. That is my prefix. I'll need a chemoreceptor to detect that. The chemoreceptors that detect changes in pH in the body, we find them at different locations. Some of them will be located in the medulla oblongata. Some are found in the major arteries. And these are for example, the carotid artery, around the neck region, and the aortic arc, which is the arc formed by the big artery that leaves the heart to supply blood to the head and to all other parts of the body. So that arc, we call it the aortic arc. It has some chemoreceptors. So there are three places here where we find chemoreceptors. But for our essay that we are going to have at a later stage today, we will mostly focus our attention on the receptors that are found in the medulla oblongata so that we don't complicate our lives. But otherwise, you can find other receptors here. So we have receptors there. Now, we've cleared out pH, blood pH. We've also realized where our receptors are found. I think we can start the essay now. Simply put, in summary, we could say, first point, when the level of blood pH decreases due to an increase of carbon dioxide concentration, CO2 concentration, or you could say as carbon dioxide concentration increases in the body, blood pH decreases. Next point, what happens? Chemoreceptors in the medulla oblongata detect a decrease in blood pH. So you should know at this point, decrease in blood pH means increased acidity. This is the effect of our hydrogen ions. Next. The medulla oblongata is stimulated and sends a message to the heart and breathing muscles. So a message is sent to the heart and to the breathing muscles. These muscles include the intercostal muscles. If you've ever eaten spare ribs at Spur, then you are busy eating intercostal muscles. So it includes the intercostal muscles and the diaphragm. Muscle of the diaphragm. The diaphragm is that sheet-like structure, sheet-like muscles that separate the thoracic cavity from the abdominal cavity just below the lungs. So the message is sent to the heart and breathing muscles, which are the intercostal muscles and the muscle of the diaphragm. And what does that message do to the heart? The heart rate increases and blood is transported faster to the lungs. Therefore, blood needs to be sent to the lungs because this blood will be carrying a lot of carbon dioxide. That's why the heart rate has to increase. We remember here that one of the functions of the medulla oblongata, since it functions mostly in controlling involuntary actions, one of its functions is to regulate heart rate and breathing rate. So the first message causes an increase in the heart rate so that more blood can be transported and faster to the lungs. Secondly, the breathing rate also increases because the breathing muscles, that's the intercostal muscles and the muscle of the diaphragm, become more active. They're active, they contract and relax very fast so that they send out carbon dioxide very quickly. The breathing rate increases because breathing muscles become more active. And what is the result of that? More carbon dioxide is sent out of the lungs. It's sent out of the lungs, and the level of carbon dioxide in the body decreases. So that's it. Usually, you would say more carbon dioxide is sent out and more oxygen is taken in. That is what happens in actual fact, but I don't usually agree with the statement of more oxygen taken in, because here our main focus is the level of carbon dioxide. It is the one that is creating toxicity and is the one that needs to be balanced. So our story here should end within the scope of carbon dioxide on its own, not about oxygen. Oxygen doesn't necessarily come to balance the level of carbon dioxide. In the equation that we had earlier, you will not see that oxygen is there to try to reduce carbon dioxide. No. We're taking out carbon dioxide to reduce the level of hydrogen ions, to reduce acidity. So oxygen is not necessarily part of this, although it is true that when you breathe in fast, you're taking in oxygen, you're taking out carbon dioxide. But our center of concern here is carbon dioxide. That is the essay. I hope we all understand very well. Thank you for attending. You may enjoy your day.